Now let's consider a graph of v versus t. And this is the velocity of some object versus time as measured by some sort of a clock. We have 2 points on this graph. Okay, the first point, of course, has an x-coordinate or t-coordinate and an x-coordinate. I'm going to call the t-coordinate t0 or t0. And I said x, it's v. The v-coordinate we'll call v0. Second point, we'll have coordinate that we'll call t sub f, and a velocity coordinate that we'll call v sub f. So these 2 points can represent the velocity and time measurements for an object on some interval. Now the interval runs from time t0 to time tf, and the velocity changes from v0 to vf. The change in t is therefore could be represented by an arrow from here to here, and the change in v could be represented by an arrow from here to here. Let me make sure we got that arrow. I think we got it, but just in case, I'm going to cheat a little bit. Okay? So again, our 2 points then represent 2 events. The velocity being v0 at time t0 is the first event. Second event, velocity vf at time tf. We have a change in time, change in the clock time between here and here, which we could call delta t. We have a change in velocity, which we could call delta v. And again, let's be sure I've got that. I'm going to cheat even just a little more. There's some glare. I'm not sure how well or how visible that is. Okay. So from this graph, if we can measure the coordinates, we could calculate the average velocity. I'm sorry, the average rate of change of velocity, the average acceleration, which is delta v over delta t. So if we know t0 and tf, we can find delta t. If we know v0 and vf, we can find delta v. Now we don't necessarily know what the object does between this event and this event, but let's assume that the velocity is behaving continuously and that this is a small time interval and a small change in velocity, and then assume that the graph doesn't deviate much from the straight line between these 2 points. In this case, we can see that delta t is the run between the 2 points. Delta v is the rise between the 2 points, so that the slope represents delta v over delta t, which equals the average acceleration. And we can say even more. To the extent that the line, that the graph between these 2 points is a straight line, the average velocity will occur at the midpoint of the interval, and it will be halfway between vf, v0, and vf. So here is our average velocity. Now this is very important, so I've written it down. Again, what I just said, to the extent that the actual velocity doesn't deviate much from the straight line segment, The average velocity is going to occur at the midpoint of the interval, halfway between T naught and TF, and halfway between V naught and VF. And since it's at the midpoint of the interval, you can understand why, and you should think this through. The average velocity is therefore equal to VF plus V naught over 2, which is the average of the initial and final velocities on the interval.